Let's start by looking at the output from this post processor. Line 1 is the job number in a way which is recognized by most professional machines, 00055, followed by a comment, normally a drawing number, or title, but here just a file name. Line 2, this is the CNC name, it can be set to your personal system. Line 3, this is the compile date, the date you pressed OK. Line 4, this line is here to remind you to enter the cycle time, when the job is finished, so as the next time you come to run this program again, you will know how long it will take. Line 6 is irrelevant unless you have the custom screen set we are using, it can be ignored, or removed from the post processor, it is used to automatically set the tools into Mach 3 tool list. I will show you a manual way to do it later. Line 7 and 8, these are the default settings, they place the CNC into a safe mode. G20 and G21 unit selection, G21, program G20 to use inches for length units. Program G21 to use millimeters. It is usually a good idea to program either G20 or G21 near the beginning of a program before any motion occurs, and not to use either one anywhere else in the program. It is the responsibility of the user to be sure all numbers are appropriate for use with the current length units. See also G70/G71, which are synonymous. G17, G18 and G19 plane selection, G17, program G17 to select the XY plane, G18 to select the XZ plane, or G19 to select the YZ plane. The effects of having a plane selected are discussed in under G2/3 and CAN cycles. G90 and G91 distance mode, interpretation of Mach 3 code can be in one of two distance modes, absolute or incremental. To go into absolute distance mode, program G90. In absolute distance mode, axis numbers, X, Y, Z, A, B, C, usually represent positions in terms of the currently active coordinate system. Any exceptions to that rule are described explicitly in this section describing G-codes. To go into incremental distance mode, program G91. In incremental distance mode, axis numbers, X, Y, Z, A, B, C, usually represent increments from the current values of the numbers. I and J numbers always represent increments, regardless of the distance mode setting. K numbers represent increments in all but one usage, the G87 boring cycle, where the meaning changes with distance mode. G40, G41 and G42 cutter comp, to turn cutter radius compensation off, program G40. It is okay to turn compensation off when it is already off. Cutter radius compensation may be performed only if the XY plane is active. To turn cutter radius compensation on left, i.e., the cutter stays to the left of the programmed path when the tool radius is positive, program G41D. To turn cutter radius compensation on right, i.e., the cutter stays to the right of the programmed path when the tool radius is positive, program G42D. The D word is optional, if there is no D word, the radius of the tool currently in the spindle will be used. If used, the D number should normally be the slot number of the tool in the spindle, although this is not required. It is okay for the D number to be 0, a radius value of 0 will be used. G41 and G42 can be qualified by a P word. This will override the value of the diameter of the tool, if any, given in the current tool table entry. It is an error if the D number is not an integer, is negative or is larger than the number of carousel slots, the XY plane is not active, cutter radius compensation is commanded to turn on when it is already on. The behavior of the machining system when cutter radius compensation is on is described in the chapter of cutter compensation. Notice the importance of programming valid entry and exit moves. G43, G44 and G49 tool length offsets. To use a tool length offset, program G43H, where the H number is the desired index in the tool table. It is expected that all entries in this table will be positive. The H number should be, but does not have to be, the same as the slot number of the tool currently in the spindle. It is okay for the H number to be 0, an offset value of 0 will be used. Omitting H has the same effect as a 0 value. G44 is provided for compatibility and is used if entries in the table give negative offsets. It is an error if the H number is not an integer, is negative, or is larger than the number of carousel slots. To use no tool length offset, program G49. It is okay to program using the same offset already in use. It is also okay to program using no tool length offset if none is currently being used. G80 cancel CAN cycles, program G80 to ensure no axis motion will occur. It is an error if axis words are programmed when G80 is active, unless a modal group 0G code is programmed which uses axis words. G94 units per minute, in units per minute feed rate mode, an F word on the line is interpreted to mean the controlled point should move at a certain number of inches per minute, millimeters per minute, or degrees per minute, depending upon what length units are being used and which axis or axes are moving. G68 and G69 rotate coordinate system, program G68ABIR to rotate the program coordinate system. A is the x coordinate and B the y coordinate of the center of rotation in the current coordinate system, i.e. including all work and tool offsets and G52/G92 offsets. R is the rotation angle in degrees, positive is CCW viewed from the positive Z direction. Program G69 to cancel rotation. Notes: this code only allows rotation when the current plane is XY. The I word can be used even if the center point is different from that used before, although, in this case, the results need careful planning. G70 and G71 units, program G70 to use inches for length units. Program G71 to use millimeters. It is usually a good idea to program either G70 or G71 near the beginning of a program before any motion occurs, and not to use either one anywhere else in the program. It is the responsibility of the user to be sure all numbers are appropriate for use with the current length units. See also G20/G21, which are synonymous and preferred. G90.1 and G91.1 set IJK arc mode. Interpretation of the IJK values in G02 and G03 codes can be in one of two distance modes, absolute or incremental. To go into absolute IJ mode, program G90.1. In absolute distance mode, IJK numbers represent absolute positions in terms of the currently active coordinate system. To go into incremental IJ mode, program G91.1. In incremental distance mode, IJK numbers usually represent increments from the current controlled point. Incorrect settings of this mode will generally result in large incorrectly oriented arcs in the tool path display. Further information on G-codes can be found in the Mach 3 folder with the name Mach 3 mildcode.html. Line 9 is set depending on how you set the G53Z0 in the post processor. Line 10 tells you whether you are using the imperial system or the metric system. This depends on which post processor you choose. Line 11, this is set from within the post processor depending which work offset you selected. G10 tool offset and work offset tables. To set the offset values of a tool, program to set the coordinate values for the origin of a fixture coordinate system, program G10L2PXYZABC, where the P number must evaluate to an integer in the range 1 to 255, the fixture number, values 1 to 6 corresponding to G54 to G59, and all axis words are optional. The coordinates of the origin of the coordinate system specified by the P number are reset to the coordinate values given, in terms of the absolute coordinate system. Only those coordinates for which an axis word is included on the line will be reset. G10 tool offset and work offset tables. Line 12, This is set from within the post processor depending which work offset you selected. G54, G59 and G59P1-254 work offsets. To select work offset number 1, program G54, and similarly for the first 6 offsets. The system number G-code pairs are 1 G54, 2 G55, 3 G56, 4 G57, 5 G58, 6 G59. To access any of the 254 work offsets, 1 to 254, program G59P where the P word gives the required offset number. Thus G59P5 is identical in effect to G58. It is an error if one of these G codes is used while cutter radius compensation is on. Line 13, this is set from within the post processor depending which mode you selected. G61 and G64 path control mode, program G61 to put the machining system into exact stop mode, or G64 for constant velocity mode. It is OK to program for the mode that is already active. Line 14, this is set from within the post processor depending which option you selected. G68 and G69 rotate coordinate system, this has already been explained. Line 16, prior to line 17, tool call, if the tool description is added. Line 17, this is the tool call, M06, tool change, T1, call tool number 1. Line 18, this turns the spindle on, at S12000 RPM, M03, spindle clockwise, F1200, feed. Line 20, is the first point in the pocket named above, and it's the starting location. Line 21, this is set from Z gap above material, G0 Z20.00. Line 22, if you have set option stop in Mach 3 to on, the program will stop, until you press the green button again. This gives you a chance to see if you got the tool length right. Line 23, the tool will rapidly move to the clearance, Z1, height, this is the height you believe will clear any obstructions. Line 25, now the tool will rapidly move down to the plunge, Z2, height, this is the height you consider to be a safe height to begin cutting. Line 26, the cutter will start to plunge into your job to the program depth, and then continue to machine the pocket. From here on it depends on your job requirements as to what goes on. Jumping from one pocket or tool path to another will go something like this. Lines 55 and 77, the tool will be raised to the clearance, Z1. Lines 56 and 78, rapidly move to the next starting point. Lines 57 and 79, the tool will rapidly move down to the plunge, Z2, height. Lines 58 and 80, the cutter will start to plunge into your job to the program depth, and then continue to machine the pocket. This sequence will continue over and over again, until all the tool paths have been completed for that tool. When the tool has completed its task, in my case line 5887, the end sequence will start. Line 5888, as always the tool will rapidly rise to the clearance, Z1, height. Line 5889, depending on how you set G53Z0, one of two things will be added, G53Z0 no, G0 Z20.00, ZHZ gap above material, will be added. Line 5890, the spindle stop is added, M5, spindle stop. The sequence from line 16 to 5891 will repeat until all the tools have done their programmed work. 16, to 5891, 5892, to 14699, 14700, to 15,089, 15,090, 2, 15,821. Line 15,822, the line G69, cancel job rotate, is added. Normally it will do nothing, however when you have rotated the work it's always best to cancel it. Line 15,823 depending on how you set G53Z0, one of two things will be added, G53Z0 no, G0Z20.00, ZHZ gap above material, will be added. G53Z0 yes, G53Z0.00, Z machine 0, will be added. Line 15,824, M5, spindle stop. Line 15,825, one of three lines will be added here depending which option you selected, G53Z0.00, Z machine 0. G28X 0.00Y 0.00. G00X 50.00 Y 250.00. Line 15,827, can be ignored, it will do nothing. Line 15,828, M30, this is the end of program command, everything will stop, and after you have cleaned away all the chips, you can stand proud, and admire yet another excellent job. This has turned out to be far longer than I expected. I wonder how many of you lasted this long?